Welcome to Physics Made Easy channel, and we are solving NCERT problem in this session. So let us see this problem. In Young's double slit experiment, the source is white light. One of the hole is covered with red filter and another is covered with blue filter. One is covered with red filter, it means only red wavelength will come out. And other with blue filter, it means only blue wavelength will come out. It means one wave that will come out that will have wavelength approximately 7800 angstrom. Other somewhere near you can say about 4000 angstrom. I'm taking rough values, not exact value. Driving the point that the wavelength, these two wavelengths, they are different. And if wavelengths are different, it means frequencies are different. And for coherence to take place, frequencies, for coherent sources, frequencies should be same. And there should be definite phase difference. But here the very first factor that the frequency should be same has been violated. Now let us read the choices. Now he says there should be alternative interference patterns of red and blue. There should be an interference pattern for red distinct from for blue. There should be no interference fringes. There shall be an interference pattern for red mixing with one of the blue. Answer C is correct. Because for sustained interference, we need coherent sources. And coherent sources are the sources which are having same wavelength or frequency. Their different frequencies will ensure that their sources are incoherent. If sources are incoherent, frequencies are different, it means interference pattern cannot be observed. Now let us see the next question. Figure shows a standard two-slit arrangement. Basically, here is a two-slit arrangement. This is a source, this is slit S1, this is slit S2. These two sources, they are not equidistant from the point P. So what he says here is minima. Here is also minima. And here is another slit S3 and S4, they are equidistant from P2 and second screen. Now, we have got two cases. What he says, there would be no interference pattern on the second screen, but it would be lighted. The second screen would be totally dark. There would be a single bright point on the screen. There will be regular two-slit pattern on the second screen. So the answer to this problem, first the question has not been correctly asked to my mind. The answer to this problem basically will be divided in two parts. First part is A part. In this case, slit width, I will call this width to be small a. and the width of this slit also as small a. In the first case, I will take slit width too much greater than lambda. In this case, only interference will take place. And diffraction will be negligible in this case. In this case, in interference pattern, minimas are completely dark. Minimas are completely dark. Now, in first case A, this will be completely dark. Completely dark means intensity here will be 0. And no source of light, no pattern. No interference pattern or no pattern here. Now I will take B case. When the width, and change the color because we are discussing the same thing on the same base. So in this case, if slit width is much less than lambda, now interference and diffraction will take place. So I will treat it as diffraction case. Because of diffraction element, in diffraction, note this case, minimas are not completely dark. Minimas are relatively dark. So in that case, intensity here, red case represents second case, will not be 0. So it means some light will go like this. And this may form interference pattern here. So in this case, there will be interference pattern or some kind of pattern, because here the width is very large. Note it down. Here the width is very large. Here slit width is small. So it means in this case there will only be interference pattern. And in the first case, so I have divided in two cases. If only interference takes place, then minimas are completely dark and there will be no fringe pattern on second screen. And if this slit width is lesser than the wavelength, then interference and diffraction both will take place and intensity here will not be 0 and we shall observe an interference pattern. I have now taken here only interference pattern because in this diagram slit is very wide. In this diagram slit is not that wide. That's why I have taken this liberty here. And now let us deal with the next problem. Next problem is here. Now we have got the problems where answer is more than one. So this is the problem. Two sources S1 and S2. These are the two sources S1 and S2, and their intensities are I1 and I2. S1 and S2 are two sources. Their intensities are I1 and I2. The pattern of intensity distribution seen in the central portion of the figure B. This is basically interference pattern. Now it means if this is interference pattern here, this is interference pattern basically. It means interference takes place. If interference takes place, in interference, intensity of S1 and S2 is not at all relevant. So for interference, there should be constant phase difference between S1 and S2. Option B is correct. S1 and S2 may be in same phase. This is also correct. S1 and S2 have same wavelength. So it means B, C, D. These three are the basic conditions for coherent sources. So B, C and D, all the three may be correct. In fact, they are correct, not may be correct. And the next case is this. Seventh problem. Seventh MCQ. Consider the sunlight incident on a pinhole. Now this is the pinhole. Size of pinhole, I will take it as A. Size of pinhole A is approximately 1000 angstrom. Not it's exactly. Now sunlight is white light. I will take it as white light. Now wavelength for white light varies from roughly 3800 angstrom to, I will like to say red for red. It is 7800 angstrom. So what this clearly shows that a size of the slit is much lesser than the wavelength. It means in diffraction will take place. So this is a typical case of diffraction. Now the image of the pinhole screen seen on the screen is wrong. It will not be sharp white because diffraction will take place. So there will be some encroachment of the shadow different from geometrical image. This is correct because encroachment of geometrical shadow by light, which is called diffraction, so it will produce some kind of difference between the image and the object. A diffuse central spot, white in color, no, not at all, it is absolutely wrong. Central spot will be bright because if you remember the diffraction pattern, so this is the diffraction pattern. There is a central maxima and then it is flanked by minimas like this. So this is central maxima. So central spot will be bright. Diffused color region round a sharp white spot. This is correct. D is correct and B is correct. Now why there will be diffuse color? Because the condition of minima is this dependent upon lambda, and that for maxima is this, which is again dependent upon lambda. So due to this lambda factor and this lambda factor, Particularly, these lambda factors are relevant in all other maximas and minimas except the central maxima. The central maxima will be sharp and these regions will be diffused. Why diffuse? Because intensity will reduce and the white light will break up in about 7 patterns. So this is the basic reason. And the next question is, consider the diffraction for a small pinhole. The hole size is increased. As the size of the hole is increased. Now, consider the diffraction pattern for a small pinhole as the size of the hole is increased. If we increase the size of the hole, one condition may arise that A may become larger than lambda. In that case, diffraction will not take place and there will be no encroachment of the shadowed area. So in this particular case, when diffraction stops taking place, then option A is correct. If you first size is very small, it means diffraction is taking place and the size of the image is larger than the size of the hole. Why? Because of diffraction. As we are increasing the size of the hole, at a particular point, the size of the hole will become larger than the incident wavelength at that time. As we increase the size of the hole, diffraction will decrease. If diffraction decreases, then the size of the hole as shown on the screen will also decrease. So A is correct. And then the intensity increases, the size increases, the intensity decreases. Now he says that the intensity increases, more and more light will be incident, so intensity will increase. So there is no second thought about this thing. And the next is last question. For light diverging from point source, wavefront is spherical, quite clear. The intensity decreases in proportion to the distance squared. This is also correct. Wavefront is parabolic, absolutely wrong. The intensity at the wavefront does not depend upon the distance. This is also wrong. So the two choices A and B, they are correct. So with this we have finished NCERT Exemplar MCQs, and in my next lecture we shall be solving other exemplar problems. And now I finish this lecture and thank you very much for being with me for 18 minutes.